Oh, hey everybody, Daniel here from Basement Tech. Not sure which number this is in the series, but it does remind me, I want to mention that I renamed the videos. Actually, all I did was add sort of an index number behind them to indicate kind of the recommended order to watch the videos for this monitoring zimKnives project. It's not critical, but I think if you watch them in the order that they're indexed, it might make a little more sense. Secondly, do remember that all of this software code, even some schematics, are available on the Basement-Tech GitHub. I'd be happy for somebody to download it, take a look, try to use it, and provide some feedback in the comments. That would be great. I do want to start out too with one other sort of generic. Let's see if I can get this to pop up here. Okay, so I'm back to the system diagram. It occurred to me I wanted to point something out. If what you're interested in doing is a remote display of some environmental variables, we have the remote sensing unit here that sends data over Wi-Fi and is received by the Mosquito data broker. If what you want to do, if all that you want to do is display those values on a pretty neat graphical user interface, you really don't need any of this Python code. Remember, the Python is serving two functions. One is collecting data from other sensors that are directly connected to the Pi, and secondly, providing the alarming logic. So again, if what you're interested in is just a really neat remote environmental monitoring system, you don't need any of the Python. However, if what you're interested in is all of the goodness that is this alarming system, then let's get into the Python. George, one of the subscribers, mentioned, "Hey Dan, it'd be really cool if you took that configuration stuff, like pin numbers and timeouts and all of that kind of thing, and put it in a configuration file." It turned out I had already done that, but I did want to mention one design decision that I made. I could have used either Python, or it's very common and popular to use a JSON configuration file. I looked at the Python dictionary and thought, you know what, it's completely readable, understandable, and I'm writing in Python and I want to learn more about Python, so why not make a Python dictionary for my configuration? So what you see on the screen here in this file, which is a separate file that you'll find on GitHub, this monitoring configuration, and the gen is just generic. I genericized it to be a little bit clearer. You see things like what's the location, and that's used in some of the notification messages. How is the hardware connected, etc., etc. And this is what would allow you to reconfigure the system for your specific needs or your specific hardware connections, for example, without having to get into the guts of the Python code. Okay, now on to the main Python file, if you will, this monitoring_local.py. Last time I talked about the much lower level classes that handle the parameters that we want to deal with, both hardware and virtual/logical. This time I want to show you how we use those classes to implement the alarming logic. So I'm going to slide all the way to the bottom. I've been maintaining through these videos that using classes and following some design tenets allow you to have a really concise and clear loop at the bottom when you finally get that far. So here we are, all the way at the bottom at main loop, as the comment says. It's a while loop. In all of these kinds of applications where it's just going to continuously run, I think you would have a while true. And then I'll come back to this exception handling in just a second. I think you can see this loop is very small and very understandable based on clever designs of the classes and variable naming. So reading through, you can see what it does. I sync the data. I do have a local copy of the data, and I'm going to come back to that in just a minute. Process the alarms based on the data that I've both received from the remote sensor and locally from my locally connected hardware. Manage alarm overrides. Remember, I'm doing remote control from the Node-RED dashboard. That's this function call here. Finally, service the things that are physically connected. If I'm in debug mode, I display the values of all of the variables and then finally check on the status of my connection to the Mosquito data broker, and if there's an issue, try to reconnect. That's it. That's the application. Get the data, look at the data, make appropriate decisions about alarming, and loop around and around and around. Now, I mentioned this local copy of data. I don't know if I mentioned that in the last video, but I want to repeat it here if I didn't. This is a slow-moving application. I don't need to do anything in microseconds or even milliseconds. This loop runs, I think this loop delay at the bottom is configured, not in the config file, but up at the top of this file as 2 seconds. So I'm not doing these things blazingly fast. The hardware is going to capture the value of something like the motion sensor, so I'm not worried about polling in real time. So this loop is running at a speed that's on par with my environment that I'm trying to monitor. So I do make a local copy of the data. In other words, sync all of the data, and what that means is go look at the broker, bring that data down for things that are coming from the remote sensor like temperature and humidity. Look at my local physically connected things on the Pi like the motion sensor and the key switch, and then using that local copy of the data that's stored, you guessed it, in the parameters/environment classes, make decisions about what I should do with alarming. Working my way from the bottom where the while loop was up to the top, I come across these, which are the alarm responses. Imagine this whole system works by looking at the stimuluses, like the motion sensor or the key switch, and deciding which responses are appropriate. I'll come to an example of coding a response in just a second, but you can see here things you might imagine an alarming system wants to do. Send alarm messages. This gets into kind of a clever call out to the shell to send via email some text messages saying, hey, maybe some intruder is there. Send notification messages is similar, but is intended for a regular update on something like the temperature. Say something. You can see with all the comments I'm still working on this, which might be actually use a text-to-voice program to yell at somebody who might be in, or announce an alarm condition like the gas sensor is detecting high levels of carbon monoxide. Turn on a light, etc., etc. So now I have a library of responses. Let's look at how I might use one of those in response to a stimulus. Working my way up a little farther, you see that these responses and stimuluses are in a class called Manage Alarms. This one is more for organizational purposes, if you will, than representing something physical like the parameters class. But again, it makes short work, and it makes the code a lot more readable to have things like this in a class. You see I'm using again that looping construct that I talked about. The stimuluses, which I'll talk about one here in just a second, are listed here. These are the stimuluses that I want to process. I want to look at the motion detector, the temperature and humidity, the key switch, the override LED, and remember I'm just going to loop through these in that for construct that I showed in the last video. Finally, for this video, I just want to talk about what happens when a motion is detected. I do try to comment the heck out of this with capital letters. If you have a new stimulus and a new response, you just add those here in the class. If not, you can use the ones that I have, and using that config file in the beginning, you can configure your hardware on whatever pins you want to take advantage of, say, the preloaded, pre-configured stimuluses and responses. There's not a lot of rocket science here. Remember, I've got a copy in the environment class of the current state of everything in my system. What these stimulus functions do is look at that collection of data, that situation in my environment that's represented with those environment class variables, and make some decisions. So if you kind of just look through this one here related to motion, it probably makes sense what I want to do. If I'm in automatic alarming mode, and I have not previously detected a alarming condition, and the motion detector is indicating motion, do some fun things. Turn on a light, send my alarm messages, reset a timer, I'll come right back to that in a second, and move on. If, however, I'm at the end of a motion event, for example, and I need to kind of clean things up, then this else takes place. This is a little, I don't know, odd maybe in the way I coded it, but the argument here is whether to reset or not. So if I get this far and the motion value is false, then turn the light off. And that's really it. So building up a clever set of responses in a class that makes them convenient to access, then I'm taking advantage of what I know about my environment through the parameter/environment class, allows me to make these kind of really simple, clear coding coding constructs that do fun and clever things in this alarming system. So I think I'm going to leave it there for now. I'll talk about the timers coming up. Actually, let me just mention that really quickly. I'll come back to the coding of the timers, but the idea here is if I have motion, for example, and somebody's walking around in the shop, it's going to continually cause a motion event. But I don't want to bother sending a text message every few seconds. So what these timers basically do is say only send a notification of that motion every so often. And yes, you guessed it, over here in the configuration file, that's this timeout here at the bottom. So that's the idea of the timers. I'm actually having a little difficulty with that, so I may ask for some help next time from you guys to help me sort that out, but that's the idea here. So, well, I hope this gives you an idea of how important it is to think a little bit up front about the design of your software. Stick to the design tenets so you can use something like a config file. And finally, being diligent with naming and class usage so that the code is not only understandable, but to add to this code now, since it's logical and organized, it's really straightforward to add new stuff. Like next, I think I'll add a siren and maybe a new input based on, a new output based on temperature, humidity, and gas. So thanks for watching as always. If you like this kind of thing, please give it a thumbs up. If you really like it, subscribe. And most importantly, please provide your comments so that we can have a conversation about this application. Thanks, and have a good day.